Like I was like driving like well, there was also ice underneath the snow.
Okay. Happy New Year, welcome back.
Oh yeah, and then I was like here.
Okay.
It was like
Uh,
that was so sad. So
All right, so today we're just starting the next chapter. So the next chapter is all about functions. Definitely should be review stuff. So today we're just gonna discuss the basics. Functions. So remember, first definition, a function is a relationship between sets of numbers in which it has to be a special characteristic of this relationship. And the special characteristic is that for every x value, there's a unique y value. There's only one y value associated with it. So a function is a relationship between sets of numbers in which, thanks, every input or x value is associated with a single unique output or y value. A single unique output or y value. Okay? So it's just a relationship between sets of numbers in which every input is associated with a single unique output. Okay? So there's lots of different ways to represent functions. For example, you could just have a set of points, right? So you could have something like the function f is a set of points, like 0, 2, 1, 5, 3, 2, 4, 1. And that could be the function, just those 4 points, okay? And these 4 points would represent a function because for every x value, there is a single y value associated with it. The x values are not repeated. Now, in this case, there are y values that are repeated. That's okay. Okay, it doesn't matter. What matters is you can't have 2 different points that have the same x value. You can have 2 points that have the same y value, but not x values. Okay, so that's one way to represent a function. Another way to represent a function is like a diagram, an arrow diagram. Like you got a set of numbers over here. Like maybe this set of numbers is like -2, -1, 0, 1, and 2. And then you got a set of numbers over here. So maybe this set of numbers is like 2, 4, 6, 8. Okay? And then you just have arrows indicating what the relationship entails. So maybe you have an arrow going from -2 to 4. That means that the point -2, 4 is part of the function. And maybe you have an arrow going from 1 to 6. That means the point 1, 6 is part of the function. And then maybe you have an arrow going from 1 to 2. Maybe that's the whole thing. Well, in this case, it's not a function, right? Because you have an x value that's being used more than once. The point 1, 2 is included in this function, and the point 1, 6 is included in this function. So in this case, you'd say this is not a function. Okay. Another way that a function might be represented is by a graph, right? So you might just have a random graph like this. Okay, maybe they say this is f of x. So how can you tell graphically if points share an x value?
The line testing.
Yeah, the vertical line test, right? So for graphical functions, they must pass the vertical line test. So the vertical line test just states that any vertical line you draw can intersect the graph at most one time. Because if you have a graph or a vertical line that intersects the graph twice, then those 2 points of intersection will correspond to 2 points on the function or the non-function that share an x value. Okay? So that's what the vertical line test is. It just states that any vertical line can cross the function at most once. Okay, it doesn't have to cross at all. Like you could have a function that's only defined for certain x values, right? Like you could have a function that that just is part of the plane. Like for example, a logarithm function. Okay, a logarithm function passes the vertical line test, but I could draw a vertical line over here that never intersects this function at all, right? But the point is, any vertical line you draw is going to cross this graph at most one time, right? So this is definitely a function. But if I were to draw like a parabola sideways or something, like this would definitely not be a function, right? This is a non-function. Because it's really easy to see. If I drew this vertical line, it intersects at 2 points. Those 2 points would have the same x value. This is all review, right?
Yeah.
Okay. And then finally, the last way to represent a function is just by an equation, right? Like, for example, they might give you something like y equals 2x minus 3. Okay? So for these, it's a little bit harder to tell whether or not it's a function. I mean, in this case, you know it definitely is because this is a line, right? This is a linear equation. It's not a vertical line. If it was a vertical line, it wouldn't pass the vertical line test. But if it's any other type of line, like this one, with a slope of 2, it definitely passes the vertical line test, so this is definitely a function. But what you are looking for is really the same idea. Is there a way that you could substitute in one x value and get back 2 possible y values? Like, for example, suppose I had something like, what about something like 5x equals the absolute value of 2y. So in this case, if I substitute in one x value, like for example, x equals 1, all right? If the absolute value of something is 5, right, if x was 1, then that something could be 5 or it could be negative 5, right? So there would be 2 possible solutions for y values with one input of x values. So in this case, it's not a function. This is not a function. Okay? Same thing goes for if I square y or something like, suppose I had something like x equals y squared minus 1. Same deal. Like if I try and solve, if I plug in an x value and try and solve for y, I get 2 different values. Like what if x was 0? If x was 0, there's 2 different values of y that are going to make this right side equal 0. plus 1 and minus 1, right? So this is not a function either. Okay? But if I have something like y equals cotangent 3x or something like that, then this is a function, because if I substitute in any x value, there's only going to be a single trig value that pops out of this. There's no way I could plug in one x value and get two different numbers for the value of y. So this one is a function. Okay, as is this. Okay, so that's the first skill you have to have. If a function is represented any of these ways, you have to be able to tell if it's a function or not a function. That's the first thing. And the second thing you need to be able to do tonight for homework is just to evaluate a function at different points. Okay? So obviously, if the function is represented in one of these first few ways, it's super easy. Like if I said, here's f, what is f of 1? You would just have to find the point that has the x coordinate of 1. And f of 1 would be the y value at that point. Right? Same thing goes for this. If I said, what is f of negative 2, what would be the answer? It's 4, because negative 2, 4 is a point that's on this graph, or on this function, on this relation. For graphical functions, it's the same thing. You just take whatever x value they're giving you, like if they said, find f of 1, you would just go to the x value of 1, and you'd figure out what is the corresponding y value. That y value right there is f of 1. Okay? It'll be more clear than this. I mean, I don't have any axes or any like grid lines or anything like that, so it's hard to tell on this graph, but they'll make it really obvious so you can determine that. If the function is represented by an equation, that's kind of the easiest way of all. You just plug the x value in, and whatever pops out, that's the value of the function. So if I said something like f of x equals 2x minus 7x squared. And they said find f of 1/4. Okay, I mean, it's kind of a pain in the neck because it's fractions, but it's not that bad. This would be 2 times 1/4 minus 7 times 1/4 squared. So this ends up being 1/2 minus 7/16, right? Which is 8/16 minus 7/16. The answer would be 1/16. So it wasn't that bad, even though there's fractions. You can get the answer. Sometimes they'll give you a function that's defined in pieces, though, like it's called a piecewise function. Like they might give you something like f of x is equal to either 2x plus 5 if negative 1 is less than or equal to x is less than 2, or f of x equals x plus 3 if 2 is less than or equal to x is less than 5. Does that make sense? If you were to graph this piecewise function, it kind of looks like a line and then another line, right? It's a line of slope 2 and then a line of slope 1. So maybe it looks like this. It's going along, and then it's all of a sudden going to be a line of slope 1. So then it's going along like that. So maybe that's what the function looks like, something like that. Does that make sense? So if they said, here's the piecewise function, find, for example, f of 3. So what you'd have to do is look at this stuff over here to determine, well, at x equals 3, which interval am I on? Am I on the interval from negative 1 to 2, or am I on the interval from 2 to 5? It's definitely in the second interval, right? So on that interval, it's this line. So then you just have to take 3 and plug it in there. The answer would be 6. But if they asked you to find something like f of 1, 1 is in this first interval. So f of 1 would be plugging 1 in for that x value. So you get 2 plus 5, the answer would be 7. Does that make sense? So the homework is just like a bunch of problems of different types. So the way Delta Math is organized, I had to take it from a bunch of different things. So it looks like it's a lot of stuff, but they're all really easy problems. You either are just identifying whether or not something is a function. In other words, is there an x value that's used more than once? Yes or no? And then evaluating a function at particular x values. And that's it. Any questions on that? Okay, so that's it. It's yeah, sure. The homework is it's on Delta Math and it's called functions, definition, and evaluating. That's what it's called.
Can I use the bathroom when she gets back?
Yes, you may.
Thank you. Okay.